Welcome to In the Open with Luke and Joe. I'm your host, Luke Shantz, and here's my co-host, Joe Seppi. And a big welcome to our guests, Ricardo Noriega De Soto and Frank Zdarsky. Before we get to our show, don't forget to like and subscribe. In this episode of In the Open, we bring you a conversation with Ricardo Noriega De Soto and Frank Zdarsky. Both of our guests are from Red Hat's Office of the CTO. We will be discussing the open source project MicroShift. Before we welcome our guests, let's say hello to our co-host, Joe Seppi.
Hey, Luke. How are you, my friend?
I'm doing well. How are you, Joe?
I'm all right. This weather's driving me a little crazy. I've got to get some work done on my house, and there have been some beautiful days, but this weekend is going to be cold and freaking rainy, and that's when I was going to do the work, and so I'm a little frustrated, I'll admit. It's lovely out today. Tomorrow's going to be garbage.
I totally understand this. Yesterday, it was 61 degrees in Connecticut, which
it's amazing.
You know, although I would say, I was thinking about it, I'm like, wow, this is warm for winter, but then I realized it's not really winter for 4 more days.
That's true, right?
Yeah, I think in general perception, December just feels like winter, but most of December is not winter.
Yeah, the official is it called a solstice? What is it called when things kick in on the 21st or something?
I think it very well may be. I think there's one in June and then one in December, right?
Yeah, and January and February are always the rough months of winter. So we're getting there. We're getting there. Anyway.
Yeah, let's without further ado.
Yeah.
Let's see what the weather's like with our guests. Hello, Ricardo. Hello, Frank. Welcome to the show.
Hey, guys. Thanks for having us.
Hello, guys. I'm very excited to be here. Thanks for having us.
Yeah, welcome. So you both are somewhere in Europe, right? Where are each of you, and how's the weather there?
I'm based in Germany. It's already dark outside. It's freezing cold. But hey, we're all happy.
And I'm based in Madrid, in Spain, and you should move here, right? It's the land of sun. I don't know about opportunities, but about sun is it's all good.
I would love to be in Madrid. I would love it. So, once this pandemic eases up, I am coming to hang out there for sure. I'll find a way.
Sure, let me know. We can hang out.
That sounds great. I look forward to it.
Yeah, I was going to say, I miss going to conferences in Spain. There was lots. I think we went to KubeCon there at least once, and it was, fantastic time. Amazing.
The one in Barcelona, or which one was it?
Yeah, in Barcelona.
Yeah, could have met there.
The next one is in Valencia, in the coast, and it will be very nice as well.
Yeah, that's coming up soon, right?
In May, I think, next year.
Okay, May. Okay, I'm going to be there. Count me in. I will be there.
Perfect.
Yeah, let's start planning now. I mean, not right now. Let's talk about something else right now.
Well, maybe we could start with just some brief introductions. Say hello to the audience and give them just a quick understanding of who you are and what you're working on.
Excellent. Go for it, Ricky.
Okay. Well, I'm Ricardo Noriega. I'm based in Madrid. I've been living here for 12 years, more or less. But I'm from a small and beautiful city in the north called Valencia, with a P. I'm a telecommunications engineer, and I joined Red Hat about 6 years ago, more or less, as an NFB partner engineer. The purpose of that team was basically to work with major telco providers and operators and work together to enhance projects that require some, telco features. We work on OpenStack, OpenDaylight, OpenAV, and some other open source projects. Mainly, it's all open source projects. Then I moved to emerging technologies, to the team that I'm working now with Frank. It's the edge computing team, and among other things, we started the MicroShift project. And in the personal side, I love outdoor sports, mountain biking, surfing, snowboarding, things like this. But since the pandemic started, and here in Spain, the restrictions were really, really hard, I started playing a not very famous sport called, it's called paddle tennis, at least in Spanish, some translation. It's like you play tennis in some sort of a cage, and you play like doubles, right? And I'm really addicted to it now. Yeah, I also like music, photography. Yeah, that's basically it.
Cool.
Excellent. So my name is Frank Zdarsky. I'm a senior principal software engineer at Red Hat. I've joined, well, it's now 7 years ago, coming from NEC, the Japanese network equipment provider, where I've been leading their mobile network R&D, right? So my team has been doing research on everything from like the radio base stations to the service delivery platforms. And then those 7 years ago, in the telco industry, there was all this hype about the transformation towards cloud, right? Moving from those physical appliances, these huge things, to software-defined telco networks, and then eventually moving to those to the cloud. My team has actually been one of the first to put a 4G network onto AWS. So back then, basically, Red Hat passed by and said, hey, we'd love to do this open source. Why don't you help us with that? And so back then I joined and built a team. Ricky was actually one of my first hires. And he's awesome. And as Ricky said, we did the enablement of 5G networks. If they're running on OpenStack, if they're running on Kubernetes these days, it's in large part to the awesome engineers I have on my team and that did the enablement. And now since 2 years around, I'm doing this enablement for edge computing, actually. Yeah.
Cool. That's fascinating. So I'm curious. You're both on the emerging tech team. What sort of things are you working on there, generally speaking?
So the emerging technologies team in Red's Office of the CTO has this mission to observe what's going on in the industry, what new technologies are coming up, and then kind of filter out of the noise of all the things that are going on in our ecosystem, those signals that of change that may be disruptive to Red Hat and its business and its customers, right? And then we evaluate those signals. We do POCs, play around with lots of new and cool technologies and see what's behind the hype, right? And if it's more than a hype, right? If you can see, okay, there is actually a great use of this for our customers and there's a gap in our product portfolio, then we help kind of shepherd these technologies into Red Hat's products.
Cool. Are there things that you've worked on in the past or that you see coming up besides our topic today that's of interest from emerging tech?
So our team is organized into like different technical areas. So we have a storage team, we have a security team, and a networking team, computational infrastructure team, and we are the team that's currently working on edge computing, as I said. What topics are coming up? I mean, it's in all of these domains, there are super interesting changes from the secure software supply chains to new hardware platforms like RISC-V based platforms and quantum computing, etc. To then in the edge computing, which is a super diverse area from like something that looks as big as a data center down to these small IoT devices and lots of things in between. And so we have been working on various technologies in that space. So for example, how do you roll out software hardware stacks in masses of hundreds of thousands of stacks and ensure that there's very little configuration drift between these deployments, because that's kind of one of the prerequisites to for cost-efficient operations and management, if you want. Right? Yeah, and MicroShift is just the latest project we've been working on.
It seems like such a fascinating place to work because you're getting to like you're on the cutting edge of stuff, but it's things that have a time horizon that's like foreseeable. So it's like almost like applied research space, right? Where it's like you're getting to do all the cool new stuff, but it's like it's not decades away. It's like a couple years away.
Right. Also, it's kind of stressful in the sense that you have to learn a new thing. I mean, it's fun, but you have to learn a new thing every, I don't know, 3-6 months. And the ramp up is not always easy, and timelines, things like this. But yeah, I feel very privileged to be part of the team that I'm working now.
Yeah, it sounds exciting. Not necessarily easy, but exciting.
Yeah.
I'll ask because I would if I wasn't in such a great role myself, I would be like, how do I work with these two? Or are you two hiring? I'll go ahead and throw that out there.
So I just make a blanket statement that we're always looking for good people, right? So yes, I mean, I actually am looking for a great software engineer that's versatile. As Ricky said, you need to be able to work from distributed systems down to the systems level to the hardware level. That's what makes it quite challenging, and get into new technologies and be able to do POCs. So that is quite a challenging task, I would say. But then again, just apply. We're always looking for good people, right? If we find someone that maybe not be a good fit for our team, there's so many opportunities in Red Hat, and we just connect to any of the other teams there, actually.
Yeah, great. Cool. So we're here to talk about Microsoft.
MicroShift.
Oh, MicroShift. That makes more sense.
I knew it was going to happen. I knew it.
I'm going to edit that out for the podcast version, Joe. Don't worry. So yeah, let's talk about it though. So how did this project come to be? What need is it filling, and what's sort of the impetus that arose to the rise of this project?
Yeah. So as I mentioned earlier, edge computing is really a huge spectrum, right? On the one extreme, some of what our telco customers are doing, they're basically running micro data centers, micro clouds in every city, right? So what technologies do you use there? Well, if you're doing infrastructure as a service, you use OpenStack. If you're using applications or container platforms, then of course it's going to be Kubernetes. But it really, really looks like a small data center. And from an operational model, if you have the full automation worked out, then it's really not that much different to what you're doing in the cloud. And I said the other extreme is really when you have these things like cameras and light switches and sensors, whatever. They're actually microcontroller based, right? And those things don't even run Linux, right? Because they're so hardware constrained. And then somewhere in the middle, there's a space of customers that are using single board computers or systems on chip, right? For use cases like robotics, autonomous vehicles, but it can be point of sales terminals, it can be digital signage, right? And those platforms are pretty resource constrained, right? They also operate very differently. They also have very different, say, environmental challenges, right? So heat constraints, power constraints, networking constraints, whatever. And we call them field deployed devices. And the challenge has been that a lot of customers say, hey, Kubernetes is actually an awesome model for software development and for managing software, for lifecycle managing it. But we would love to run this actually on these devices deployed at the thousands and hundred thousands in the field. And even though you could just throw your classical Kubernetes distribution onto these devices, I would argue you make very different engineering trade-offs when you optimize for these kind of use cases. And so we were basically starting to explore what would it take to take run a commercially supported enterprise-grade Kubernetes distribution like OpenShift on these low-end devices deployed in the field. And that's basically this experiment, this software project is basically MicroShift.
So interesting. And this is the space that I'm particularly passionate about. And for folks who aren't familiar, there's all kinds of, it's really like a renaissance of development boards. Like this is a NVIDIA Jetson Nano. We've got, Raspberry Pis, and obviously probably not going to go this small, an ESP, but it is such an interesting space. And there's so many choices for developers to tinker and play with these things. But as you mentioned, to be able to do it securely for the enterprise and tie this into your whole sort of, DevOps and deployment, it's not a trivial task. And you don't want to just be, download that community edition of Raspbian and think you're going to run your, your data center, or your bank, or your farm on it.
That's exactly the case, Luke. Because, we're all tinkerers, right? We all have these kind of boards at home. We're so happy to run our, our home entertainment system, or, my, actually just bought a house and trying to get more into the smart home space. So I'm super interested in these hardware platforms. But yeah, at the end of the day, there's this huge difference between these consumer grade boards, and then you put the default distribution, be it the NVIDIA Linux distribution or the Raspbian. And if something goes wrong, if something breaks, then who fixes it? Who do you call? At the end of the day, you're basically browsing the net for quite a long time, and there's a huge community out there that's super helpful, right? But if it's mission critical, no. So this is where basically all the vendors like Red Hat, make money with this commercial support.
Even in the artificial intelligence space, for example, people want to run data inference where actually the data is created, right? So they want to run algorithms, AI algorithms and machine learning algorithms in those boards next to where, I don't know, they have placed the cameras and things like this. So in the end, they want to manage the same way that they do it in the cloud. So MicroShift is, a good example of running such an application there.
Well, it's interesting that you say that too, because I'm curious, what's the difference between running it, in the cloud and on these edge devices? And what I'm thinking about is, part of how we became aware of this project and your team and the efforts is our conversations with Naeem Altaf, the space CTO, space tech CTO for IBM. And he's talking about launching things into space. I imagine, you can't just monitor or engage with those sorts of things. You're sort of set it and forget it, just shoot it and see what happens. So what's sort of the differences there in terms of running on your cloud that you can kind of interact with, or shooting it off into space and you're good luck.
Again, I would say that again, it comes down to fundamental design decisions, right? In the cloud, you're fundamentally designing for scale out, right? You're basically adapting the capacity to your demand. So, if you have a burst of work to do, well, then just add a couple of more machines and distribute the load over more machines, right? That's one fundamental aspect. That's not true at the edge. At the edge, you are resource constrained. You have the resources that you have. If you're running out of memory, out of CPU, tough luck. Your application needs to deal with that. The other part is the operational model, right? So you can assume that generally network is high speed, low latency, mostly available. Sometimes these compute nodes in the cloud, they die, right? There's this horrible pets versus kettle, analogy. So you're basically just replacing the server and put the load somewhere else. Well, you can't do that if you're talking about one compute unit on a satellite, for example, right? And obviously, network connectivity to the satellite is extremely high latency. It's bandwidth constrained. It's expensive. right? So, and obviously, there's nobody that can just fly up there and pull out the device and plug in a new one if it fails, right? So there are fundamental differences between the edge computing and cloud computing in many ways. And this is why I said, we need to actually design for these different constraints.
Yeah, one of the, maybe I'm going on a tangent, but one of the projects that we work on with MicroShift, using MicroShift was a collaboration with IBM Research, and it was about federated learning. To give you a little bit of context, like federated learning is a decentralized architecture where a number of entities or parties perform data inference locally, and these parties send the result, which is basically the model, the machine learning model, to a centralized node called the aggregator. IBM Research published this amazing library that supports like a good number of machine learning models. And we work with them to make this library more cloud native, so we could run it on MicroShift. And if you think about this federated learning architecture, is very interesting because the actual data inference is performed locally at the entities, like at the edge, right? For example, it could be an autonomous car or some system or some computer in an antenna, telco antenna, something like that. And what they send to the aggregator is basically the resolution of the findings of this model. It's not the data. So privacy is kept, and it's a very good model. So it makes a lot of sense to run this architecture and these parties on small devices, and MicroShift was a perfect fit for it.
I love what Ricardo just pointed out here, and I would like to maybe just amplify the point. And I have an interesting sort of hypothetical use case. An example would be, I forget what the exact number is. It's something crazy like 4 terabytes of data an airplane creates on one flight, cross-continental flight. An amazing amount of data, all kinds of sensors and engines. So like in a scenario like this, as Ricardo's saying, you could have the model that's looking for errors running on all the embedded systems throughout. And when it finds the issue that it's looking for, it's able to send just that message of saying, hey, I found this, versus it's impossible to stream all of the data back in real time. There's as Frank mentioned, there's bandwidth constraints. But if you can be running those models on the edge where your data is being created, then with whatever bandwidth you have, you can send just that relevant message back. And and maybe folks are familiar with this sort of thing too. It's not uncommon if you have a big data set to sort of clean it up and get rid of all the data that doesn't really mean anything and save just your important data points. So it's really exciting, and especially what I love about it is that it's real, it's part of our business, and all the use cases that have to do with it. Another one that's come up recently on our show is healthcare, right? There's a project, Linux for Health. And what's fascinating about that is you get into, again, big data, you get into security, you get into all of these issues of constraints on the system. And this is an operating system that's going to be able to run, all throughout the entire estate of healthcare, right? Down to the routers, individual devices. It's fascinating. And so I love to hear these, interesting. Agriculture is another interesting use case.
Yeah.
You're absolutely right. It's super exciting because of you work on one technology and then pair up with another team that's maybe working on healthcare, or working on public transport, or working on like robotics in industrial manufacturing applications. And there's always this possibility to collaborate and create something new, and transfer from one technology, like from one industry to another, right? So in our telco customers, we did a lot of the enabling for real-time compute and extremely precise time synchronization, right, for this 5G. And it turns out the same requirements actually exists also in the industrial space, right? When you have a production line where movement of robots need to be controlled on a microsecond level, otherwise they just shoot over in their movement and potentially hurting people, right, that are working side by side. So it's super interesting.
I love the robotic space, and in fact, I just bought myself an early Christmas present. I bought myself this little Mecanum wheel robot, and I don't know if anybody's familiar with the Mecanum wheel, but it's got these little rollers on a 45-degree angle, so the thing can just move in any direction. It's like in chess, it's the bishop. It can just go wherever it wants, and the wheels are all, there's a equation for figuring out the rotation of each wheel and direction of each wheel to make it move. But like total passion, and this is the sort of thing that they even make like forklifts and factory robot or warehouse robots rather with this. But so excited about the robotic space, and that I love that when not that I don't love the cloud, not that I don't love enterprise infrastructure. I do actually find it very interesting, but when you get to these edge use cases, they usually are like very exciting.
Yeah, are you going to add cameras there?
So this one, it does not have a camera yet. This one has basically a beefed up Arduino Mega clone inside, but then it has the USB capability. So right now I'm debating, I think I'm going to put the Raspberry Pi W with this, just the standard camera on it. But then I was thinking about maybe beefing it up with some other cameras and creating like a little, bus on there using some of the ESP cameras.
Yeah, we are preparing a demo with ESP32 cameras, like very, very low end, very cheap, for DevConf, which is in January. So stay tuned.
Oh, I'm very excited for that. We'll definitely stay tuned. And this is the one that I just got, just from it's like a ESPi board. And as Ricardo mentioned, they're very affordable. I think this is like $20. But I think for a lot of the use cases, you don't really need that much resolution or a very good image quality. I think you can have double-digit resolution image and still have 80 or 90% of the results you'd have from like an HD or a 4K image when you run the computer vision algorithms on it.
It's just more data that you throw away, right? When you have high resolution.
That's true.
Exactly.
Yeah.
I was actually really surprised to find that out. I was researching that on some project, and I was like, "Oh wow, you don't even need that much resolution to do all this heavy lifting."
So I'm curious, the MicroShift project, like how long has this been going on? Where do you feel like you are in terms of the life cycle of the project? Is it production ready? How mature is it? Should people be using it? Tell me more about that sort of part of the story.
So we've actually started this project back in May, right? Just trying to figure out how do we, base MicroShift off of OpenShift. How do we integrate those various components? I think we had the first cluster, if you want. The first OneNode version of OpenShift running. Mid-June, right? But then, of course, once this is working, you need to get into this mode of, okay, how do we optimize the user experience? How do we integrate it with the operating system, et cetera, et cetera? We're now at a stage where we're quite happy with, the ease with which you can deploy and use MicroShift on Fedora IoT, on RHEL Edge, on all these operating systems designed for edge computing in the field. And we actually have like some early adopters. They're just taking MicroShift, applying it to their use case, and giving us feedback. Because what we'd love to hear is, what works well, what doesn't work well, what do people want. how do they want to use MicroShift, and then evolve from there.
Yeah, if you see the GitHub page, there are, when you create a project like this, it's very exciting to see the number of stars increasing, the forks, things like this. It's very exciting. And as a joke, like we achieved our first goal in 1 month, and we spent 6 months refactoring and testing. So it's like always.
Yeah, red, green refactor, right? Get it working. Okay, now how do we make it better?
Right.
Cool. So so it sounds like you're still, I don't know if early stages is the right word, but perhaps not, open to the world to have everybody start using it. Is that correct? And if so, like what's next?
Well, we have, when people come across us, they immediately start using it and have their, first successes within in minutes, right? And then of course they start stretching it, right? So the first reports of, I have, I don't know, Ceph running on this thing. We're like, oh, what? I was never meant to do that, but awesome, Then Knative came next, and then somebody put a machine learning framework on it. Then somebody said, hey, do you know it actually runs at RISC-V? And we are like, oh, that's awesome to know, because we don't even have RISC-V hardware, But yeah, it's awesome to have people play around with it and contribute back. That's the fun of open source, I guess.
Yeah. What are you focused on next in terms of I don't know if feature development's the right word, but in terms of where you are and where you're trying to get to in your next milestone, for example?
Right now it's really the basic single node story, right? We wanted to have the provisioning, the upgrades, the integration into the OS, as I mentioned, ready. We want people to use it and say, okay, look, does it address a need or not? And see whether it's something that it should productize, right? And we're currently, the next step will be to actually run bigger clusters, right? Multi-master, multi-worker scenarios. We have this as an initial POC, right? We're not quite happy with the ease of use of that yet, but we're expecting to make big progress there in the next couple of weeks, actually.
After Christmas.
After Christmas, yes. Yes.
Don't put pressure, please.
Nothing happening anymore before Christmas, really.
That would be awful if Ricardo found out he had to work over Christmas on this podcast.
He will not find out on this podcast, I promise.
Something I'm curious about, because the machine learning on the edge is such a big deal, is there going to be something in MicroShift itself for managing those models, or you think there'll be like complementary products or something that already exists within the ecosystem that can be used within it?
Yeah, right now what we are basically doing is to enable MicroShift on these little boards, right? And trying to make it work in as many devices as possible and things like this. I don't think we should integrate something into the project. But for example, we have already tried to run MicroShift on an NVIDIA Jetson board. And it depends on the operating system. If the GPU drivers are available, we could use, by using the device plugin, the GPU device plugin, we could enable the GPU into MicroShift, and we could run a workload making use of this GPU. So it's basically like testing MicroShift into a bunch of scenarios and making sure that it works properly. Of course, it's a community project and there's no official support, things like this. But as Frank mentioned, we tried to run KubeVirt, for example, so we could run virtual machines on MicroShift. Another colleague tried Submariner, which is a project to interconnect clusters. So we tried that too. And yeah, the GPU enablement was more or less tested. That's it.
One of my colleagues is working on the Open Horizon here at IBM, specifically for agriculture. And the reason I was going to mention reminds me of what you were saying, Frank, about how you build something for one use case and you're like, oh, wow, it works so well over here. So Open Horizon has a bunch of retail and factory. I guess there's a big user group in China that's using Open Horizon stuff in the factory. And then they're like, hey, this is great for agriculture. So then they're putting together like a consortium of different, all different size agriculture companies. And the reason I bring it up is I know they have something in there for managing models. And I was wondering, and maybe not to answer on this podcast, but comes to mind is like, oh, I'm wondering how well these would play together if they could run, basically run Open Horizon within MicroShift and maybe sort of piggyback those use cases. And then there also could be some, already enterprise folks who are using OpenShift who'd be like, oh, this is great if we can, connect these dots and run these projects together.
Yeah, absolutely. So the way we typically, and Ricky will correct me if I'm wrong, the way we typically manage those machine learning models is we say, hey, let's wrap them into container images, because then suddenly you have solved a lot of the problems around, let's say, distribution, signing, and updating the models. And generally, we try to treat all resources on a cluster, be it the models, the workloads, the cluster software itself, or in the case of OpenShift, which also manages the operating system and the infrastructure below, to treat everything as resources, as Kubernetes resources. And there's the huge advantage that you can actually reuse, your standard GitOps pipelines, the models, the way you run an agent on your device that queries the management platform for, hey, what's the new application or the new machine learning model I'm supposed to run, pulls down that new model and then locally reconciles it. So that's how we typically use these or manage these edge deployments. But we also want to be agnostic of what's the agent that's actually running on the platform and orchestrating which workload runs where. And so, of course, we've also worked with Open Horizon, right? Open Horizon is part of the Linux Foundation Edge. And Ricky's been working on a related project, the Acrano project, actually. That's also coming from that space. Did you ever use Open Horizon, Ricky?
I think there are some blueprints or projects that make use of it, but yeah, personally, I haven't tried it myself. Yeah, if you want, I can give a little overview of Acrano, for example.
Yeah, I was just going to ask, but I was muted.
Yeah, Acrano is an open source project under the LFEdge, the Linux Foundation Edge, and the purpose was to create a set of edge computing stacks that are called blueprints. And think about a blueprint like a recipe that can define like what components I'm going to run, how the infrastructure looks like, the versions of my Kubernetes clusters, etc. And I can use this recipe to deploy the same deployment at scale and with minimum, as Frank mentioned before, configuration drift or variance. Each blueprint might serve a use case. There are blueprints for IoT, for industrial, for telco, robotics, agriculture, like plenty of them. From Red Hat, we joined the project at the beginning of its foundation, and we have driven two main projects. One is called Provider Access Edge, and the other one is Industrial Edge. It's the first one is meant to target telco use cases. And as a cool output of this project, we took the work of the Provider Access Edge blueprint and use it as a platform for a keynote demo that we did in KubeCon 2019. It was in San Diego, and there it was really cool because we deploy a full open source 4G, 5G network called Open Air interface, and we managed to perform a live video call at in the States. So it was really nice.
First open source 5G, yay!
Yeah.
Build your own 5G network.
So interesting. And I mean, I feel like 5G is one of those things, there's been so much hype about it. And now, like so many things, we're getting to the point where things are really starting to happen and we're starting to see that productivity. And it's very exciting to know that, like, wow, things that used to need such heavy infrastructure are going to be able to have the bandwidth they need and be able to, have the flexibility of being, flexible edge device in other ways. So such an exciting time to see the maturity coming to 5G.
And for open source, right? Like if you think about it, in some sort of way, some components will run on open source projects and or open source technologies. Then of course companies will take that project, make it a product, and create support, stabilize it, and everything. But it's amazing to think that probably in the software running in this in the computer that is on a telco antenna is running maybe on Kubernetes. Who knows?
One thing that's come to mind, I don't think we've touched on much, but like OpenShift runs on RHEL, Red Hat Enterprise Linux, right? But we're talking about making OpenShift work on these edge devices. Do you have to do something at that layer as well, the Linux layer?
Fortunately not, no, because I mentioned earlier that what OpenShift itself does is it manages the whole stack, right? So it has what's called an operator that allows you to represent your infrastructure again as Kubernetes object. Yeah, you can say, I want these 4 servers provisioned with a certain operating system version, and this is the way I want to configure them, right? For the networking, the storage, whatever. Just make it so. And OpenShift basically takes care of this also during upgrades. It is to do that. It's co-engineered with a variant of RHEL, that's called RHEL CoreS. And RHEL CoreS is awesome in that it's an immutable container host. And you basically just as the first boot time, you pass in configuration to give its role. And its images already has everything you need there, including the kubelet. Right? So basically you pass the configuration just to immediately join it into the cluster. There's nothing you need to do there. But I also mentioned that Kubernetes, or in general, has been traditionally designed for the data center. And in the data center, if a server goes down, right, you detect it and you just reprovision it. And you can do that because you have APIs, right? You have an infrastructure as service API if you're running on cloud. You have like a BMC, an IPMI, whatever. If it's in your private data center and you're running this data center yourself. Now, the problem in this field deployed devices that I mentioned is that once you've deployed them, imagine you're pushing a software update or a configuration update, and that update for whatever reason is broken. You broke your network connectivity. In that moment, that device would become unmanageable, right? And if it's somewhere, has been deployed by a truck roll, or even in case of some of our customers, there are helicopters like screwing these devices along like an oil pipeline, whatever. It's super expensive, and it takes a long time to actually replace them, if you can ever replace them. And so you need to have an operating system that is actually designed for these kind of use cases. For example, can detect a broken change and automatically roll back and become manageable again. And these operating systems are, for example, like Fedora IoT, or also the rel variant. I've always called it rel for edge, but it's not the real name. And this operating system solves most of our problems for us, right? The automatic software update, over-the-air software updates, the rollbacks, the secure device onboarding, right? So how do you screw these devices to the wall, plug them into power by Ethernet, and walk away? That's the whole provisioning process, right? And that technology is like I mentioned, the FIDO device onboard, that taking care of this problem of how do you actually bind to a certain owner. And all of these things we can basically outsource, right? So how do you provision the initial CA bundle and security certificates, etc.? That's what the operating system gives us. And all we try to do is to be yet another workload running on that host, right? And MicroShift should be as easy to deploy as your Nginx container, right? That's the goal.
And we would treat these devices as, for example, your home router, right? You get the box at home, or you plug it, some registration and authorization processes going on, and then boom, the configuration is there, MicroShift is there.
Yeah.
It should be
QR codes is another one mentioned in the chat. Yes, absolutely. Yeah. Basically, exactly like your devices that you buy for your home use, right? It should be super easy to set them up. No more PXE booting or ISO booting, all of this stuff, meddling with the BIOS. No.
Yeah, that's really the fascinating part to me, that you can just, and I keep thinking about just shooting something into space and letting it do its thing and set it and forget it. That's really fascinating.
Well, I imagine too, if some of these scenarios, even if it's not remote and difficult to get to, sometimes there might be just so many nodes that it would be impossible to like manually do it. So yeah, it's really interesting, and I love to see, in this show especially, we love to dig into, how the proverbial sausage is made, and because it is, it's very easy sometimes to get that initial thing working, but then you hit those roadblocks, or the classic is like, oh, I worked on this project, and you come back to it in like a month or two and you're like, well, it doesn't work anymore. Where do I even start? So it would make sense that there's a way, and you all are figuring it out, to like have a platform that allows, that's built from the ground up, that lets the developer be in that really creative space, create a lot of productivity, but do it in a way that meshes with enterprise systems. I could go on about how many projects I've made that I come back to and they don't work. It's it's definitely a recurring theme in my, like, why didn't I know about documentation. Why didn't I make any? I don't know.
That's so true.
Yeah.
Well, especially for your own projects, you're just like, this is fun. I don't want to slow down. I just want to blast through it. And then it's like, sometimes it's even like the next week, you're like, what was I doing at 3 a.m. with this Raspberry Pi? I can't fix it.
That's the thing about open source, right? I mean, you can get help from others who just happen to want to work on the same project, right? And it's also about like when you say, okay, look, it's no longer useful for myself, but maybe it's useful for someone else, right? Just share it. So that's what I really love working for Red Hat now, and it really frustrated me at my previous company, right? That you're building awesome technologies, but if the company wasn't interested, you were not allowed to share it with anyone else, so that they could potentially make good use out of it, right?
Yeah.
So yeah.
And I think that's a good segue too, right? I mean, people can go to microshift.io and read more and learn more about the project. But if they go to the GitHub repo, like what would you expect people to do, and how can people get involved? And like, let's think about the sharing aspect. Like if people want to start playing with it or help or what would you advise people to do?
Well, obviously, when we built this, want to run it for our own use cases, right? I mean, Ricardo mentioned like all the use case he was super interested in, and of course, immediately he made it work for his use case. I mentioned the person doing the RISC-V enablement. We have another team member who was saying like, hey, I actually don't want to run this on Linux all the time. I'm a MacBook user and even a Windows user, and he made it run on those operating systems. And I was like, mind blowing. And yeah, I would say just try it out, see where the boundaries are. We hope to keep MicroShift really micro, like a very, very small core where lots of functionality can be added on top if and when needed. We'd just like to understand where does what we currently have inside this small core fail, right? Where is it not enough for a super interesting use case? So we'd just love to hear what interesting use cases people come up with.
Yeah, play with it, push it to its boundaries, find where it breaks and things like that, and mess around with it.
And we have a Slack channel that everyone is invited to join, and we are, the core members and the communities is there. There are great discussions. You can ask how to make it work, or even if there is a feature that you want to add. It's up to discussion. So we are there.
How does somebody find out about that Slack channel? Is it on the GitHub repo or the?
It's in the GitHub repo. Yeah, it should be right in the README, I think.
At the bottom, yep.
At the bottom.
Scroll.
Oh yeah, all the way at the bottom. Perfect. And you've got community meetings as well?
Yeah, on Tuesdays.
Cool. Great. What else do we want to touch on? We've only got a couple more minutes left, but is there anything that we neglected to mention, or anything else that you all want to share?
Good for me.
Yeah, let me throw this in. If we've had a lot of chat activity, but it hasn't necessarily been questions. Honorable mention to Tony T. Thank you for participating so much. You're very active, and you're engaged. You're even engaging with other users, which I love. That's extra bonus points there. So if anybody listening has any questions or watching, please feel free to drop them in the chat. But I think it might be interesting to hear about. We've talked a lot about MicroShift today, but what are some other things coming out of the emerging tech office of the CTO that you're excited about, and that we could talk about for the last few minutes?
Let's see. So one thing that got me super excited is a project that was actually created by a colleague of mine, Luke Hines, on Sigstore. Maybe you've had him on the show earlier, right? About the secure supply chain, with all these like attacks going on recently, vulnerabilities, Log4j, etc. So it's super important that that companies have better control of their software supply chain, right? We always think about hardware and goods in our supply chain, and mitigating risk, like that your goods don't arrive in time or in the wrong quality or defect, whatever. But to me, it was super surprising that it's been such a long time that we didn't have a great open source framework for supply chain security, actually. And Luke basically initiated these couple of projects, Recore and Sigstore and whatnot. Actually got the interest from Google, and then they basically together kicked off these projects. And actually, I'm super interested also in experimenting with these technologies and maybe using them for MicroShift as well, right? So because there's always this cross collaboration there going on.
That is interesting. You mentioned software supply chain, because I know there's been a lot this past year too with software bill of materials coming as being something I think that is, Joe, I know you know more about than I do, but something I think is going to be required. And it's interesting because, you know, obviously, you know, supply chain itself is another big issue this past year. And, you know, things that seemingly work well under certain conditions don't work well under other conditions, or have vulnerabilities, as we've seen everywhere. I mean, at the time of this recording, we are 1 week or so into the Log4j 0 day. So I think probably more people than have ever been aware of software supply chains right now than maybe have ever been. It's like, you know, Financial Times, it's on, you know, MSNBC, everyone's aware of what's going on. It's fascinating.
There are really funny memes about Log4j crisis.
You know, the memes, it's funny that you mentioned that, because I actually learned something from the memes. I didn't realize this. This was the classic meme with the guys who run that biker chop shop, and they're arguing and whatever. Log4j, the other guy is saying it's not Log4j, it's Log4j, because you're forging logs. And I was like, oh, I never even thought about that.
Oh my God.
So is it Log4j or is it Log4j? I don't know. Discuss.
Not really good marketing then.
Yeah, exactly. Open source people aren't really great at marketing at all.
I know. Our first logo was really a mess.
Yeah, that's why I recommend all open source projects join a foundation. They usually have marketing people there, designers, everything you need.
Yeah, there's many layers before a project gets to product, right? And graphic design is one of them.
Yeah. It's interesting you mentioned project to product. Anything, you know, in the future for MicroShift? Just continuing open source, or?
It's definitely going to continue to evolve as an open source project. And as I mentioned earlier, if you know, if the customers that we're currently trialing with, if they find it interesting, and you know, and say, hey, you know, Reddit, why don't you give us commercial support, right? So then, you know, let's see.
That's how it
Let's
works.
see.
Very cool.
Yeah. Fingers crossed. And the link that you see on screen is the webpage about emerging technologies and all the projects that we are working on or we started. It's very interesting.
Yeah, it's an exciting group. I encourage folks to check out that link and see what's going on over there, and keep an eye on it, because as it's titled, things are emerging. It's evolving and new stuff to hear about all the time.
Yeah.
Amazingly, we are out of time. It's been 1 hour. It really does fly by. This has been such an interesting conversation. I feel like this one especially is exactly what we want this show to be about. We really want to like look at open source, take it apart, but then contextualize it and relate it back to folks, to business and to the enterprise, so that folks kind of see that path of like, here's how you know, use it in a positive way or contribute in a positive way to get, you know, real value back. And I think it's amazing, right? I mean, it's good for the obviously done well, but it's good for the individual and it's good for the organization. So I feel like it's such an interesting topic to explore.
Most definitely.
Agreed.
Yeah.
Cool. And I'll just add to, you know, if folks are watching this now or later, if you have more questions, feel free to message us. My Twitter DMs are open. If you have any questions, feel free to shoot me a message and I'll work on getting them answered. And thank you both for your time. It was great chatting, and definitely let us know stuff in the future. If you got updates on MicroShift or something else happening, consider us a resource. We'd love to chat some more.
Sure.
It was
Thank
great
you very much
chatting.
for having us. Yeah.
Yeah, thanks for having us.
Thank you, Ricardo. Thank you, Frank. Catch you soon. Bye.
Cheers.
Bye-bye. Cheers.